We have been talking about circles for a little while now. Back in 6.1, when we first introduced them, we said the definition of a circle was that all of the points on the circle were equal distance from the center, right? Any point that falls on the actual circle is the same distance from the center as any other point that's on our circle. So this is a set of points distance from a given point called the center. This definition kind of sounds similar to the distance formula, but with a small few tweaks made to it. I don't know. It also doesn't look like this, does it, with the little boxes? I don't know why I messed up, but okay. So basically, they're saying that the point in the center is a coordinate point, and any point that falls on the circle is a coordinate point. And basically, the distance from the center to any of those points should be equivalent. Okay? So, our distance formula that we've previously seen was that distance was equal to x2 minus x1 squared plus y2 minus y1 squared. Right? Okay, that is going to be similar to what we're doing today. If I wanted to get rid of this big square root over the top of the formula, how would I do that? What's the opposite of taking the square root? Right. So I could square both sides of the equation, and then I would have d squared equals, the square root and the square root cancel out, x2 minus x1 squared plus y2 minus y1 squared. Right? Okay, they're saying this is closely related to the formula to find the equation of our circle. Your center point is going to be represented by some coordinate point HK. So here, H is going to be the X value of your coordinate point for the center, and K is going to be your Y value for the coordinate point of your center. And we're still going to plug it in to the exact same formula, but instead of it being equal to distance, the distance from the center to the edge is what we call a radius, right? So this should be helping us find the radius of our circle. So you can see they drew a little figure over here to the side. They said that HK is our center, okay? Whenever I find the distance from HK to any point anywhere on this circle, I should have found the radius. And this is going to be our formula for doing that, okay? So let's look at some examples and apply this formula. Okay, so R is our radius, HK is our center, and X and Y are just going to represent any coordinate point that would happen to fall on the actual circle. Okay, so for circle A, that would be this circle right here. Where is the center of that circle? What coordinate point is the point A at? Good. Okay, so the center is at 1610. Okay, so from the center to the edge of the circle, how many units is it, or what is its radius? 5, and these are in increments of 2, right? So this would be 10. Good. All right, so I should be able to just plug this in to this equation. So I'm supposed to have x minus h in my first parenthesis. Well, here is my h and k. So in my parenthesis, I'm going to have x minus, right, plus y minus k, and my k should equal my radius squared. Well, our radius is 10. If I square 10, what is it? And that's the equation for this circle. So if I wanted to graph this circle, this is the equation I would write down. Just like when I want to graph a line, I write down y equals mx plus b. This is what you would write down for the equation of a circle. All right? Same thing, but for circle B. This one up here at the top. Where is the center? Where is B at? 420, good. Okay, and what's the radius of that circle? Also 10, So again, here's my h and k. If I go plug these in, I'm going to have x minus squared plus y minus squared equals r squared. And r squared is going to be, very good. All right, one more for circle O, that third circle. Where is the center at for circle O? 0, 0, good. Okay, and what's the radius of circle O? Good. Okay, so if I go and substitute these in for h and k, I'm going to have x minus, right, and y minus 0 equals, right. Okay, it is not necessary to write x minus 0 and y minus 0 because it's not going to move us anywhere, right? Subtracting 0 does not change the value. So if your center is at 0, you do not have to put the plus and minus. You could just have x squared plus y squared equals your radius squared. And you don't have to put the minus 0. Okay. All right, this one, they do it the other way around. They give us the equation. They want us to determine then what the center and radius would be and go draw it. Okay, so in this equation, we have x minus 3 and y minus 2. What does that mean our center is? 3, 2. Not negative 3, negative 2, right? The formula is what puts the negatives in there. Okay, and if they have 9 out here, what is the radius? 3, right? Because we have to take the square root of that number to undo the square. Very good. So I'm going to come over here and put myself a point at 3, 2. And then I'm going to count up 3 units, over 3 units, left and right, down 3 units, so that I have a good idea of my circle. So we got 1, 2, 3. All right. And if I go and connect those points, I should have a perfect circle around my center at 3, 2. All right. All right, flip it over onto the back. And I have a couple more like this one for us to do. Okay? For this top example, where is my center? Good. And what's my radius? Okay, so I come over here, I plot my center point, and then I got to count 5 places in a few directions to have my radius. Okay, one more example. On this next one, where is my center? Very good. So remember, if you don't have anything with y, that's like having minus 0. Okay, and what would my radius be? Good. All right, so we come over here and we plot that point at our center, and we count 6 in each direction. in this next section, it says to write the standard equation of the circle from the given information. So I'm going to fill in this column here. You go write the equation for what I give you. Okay? So, first one, the center is going to be at 4, 7. Okay? And the radius is going to be 5. So, what would our equation for that be? Equals what? Good. Okay, so I'm going to finish filling in this column, and I want you guys to fill in the equations, and then we'll check the answers. So the next one, your center is going to be at -3, 8, and your radius is going to be 6.2. The next one, your center is at 2, -9, and your radius is square root of 11. Okay, the next one, your center is at 0, 6, and your radius is square root of 7. And then your last one is -1.9 and 8.7. Sorry, I couldn't put that in there, so I wrote it above it. And your radius is going to be at 3. Okay, so I'll give you guys a second to fill in what those equations should be, and we'll check in just a minute. That filled in. So on my second set of information, what's our equation going to be? Uh-huh. Good. Okay. For my third equation, what are we going to have? Uh-huh. Good. And for the next one? Nothing in there, okay. And last one. Very good. All right. Okay. Only got a couple of examples left. Okay, example 4 says to write the standard equation of the circle given the center and 1 point. Okay, the center is 3, 6, and a point on the circle is 7, 9. Okay, so if I was to write this as an equation, in my first parenthesis I would have x minus h, which would be, okay, squared, plus y minus k, which would be equals r squared. Do we know r? No. So we need to find r so that we can finish out this equation. R is supposed to be however far it is from the center to some point, right? Well, we have the center, we have some point, we just need to figure out how far it is between the two, right? So we would use our distance formula to do that, okay? So to find r, it's going to be the square root. This is going to be my x1, y1, x2, and y2. Remember, it would be x2, which for us is going to be minus x1, good, squared, plus y2 minus y1 squared. Okay? All right, so what is 7 minus 3? 4, and 4 squared is, okay, 9 minus 3 is, 9 minus 6 is, and 3 squared is, and what is 16 plus 9? Okay, so I have square root of 25, and the square root of 25 is, so now I know r. So this equation, x minus 3 squared plus y minus 6 squared equals r squared. If my r is 5, what am I going to put here? Very good. Okay? All right. One more question. Okay, it says, use this equation to answer this question. Which one of these coordinate points is not on the circle, okay? So, again, we have, it's at 3, 6, the radius is 5. I'm supposed to determine which one of these falls on the circle. So how would we do that? Plug it in and see which one gives us 5 and which one doesn't, right? Okay, so for this first one, I would have this point, right? So we would basically have the same thing that we just did, right? And did it give us 5? Okay, so this one gave us 5, this one's good to go. So it can't be that one because we're looking for one that does not work. Okay? Next problem. It should be the exact same equation. We just change out the 3 and the 7 and the 9, right? So I would have 3 minus 3, or sorry, 1, my bad. Negative 1 minus 3 squared plus, what do we have in our next parenthesis? Good. Okay, now what is negative 1 minus 3? And negative 4 squared is 16. And 3 minus 6 is negative 3, and negative 3 squared is, so we do get, okay, so it can't be that one, so it's got to be this last one, right? We've got in our radical negative 2 minus 3 squared plus 8 minus 6 squared. What is negative 2 minus 3? And negative 5 squared would be, okay. 8 minus 6 is, and 2 squared is 4. So underneath here we get 29, and the square root of 29 is not 5, so it's got to be C. Okay? So, to fill in this little part here at the bottom, since point C is not 5 from the center, then the coordinate point that they gave us, or that one, which was, what was it? Negative 2, 8, is not on the circle.